I've discussed the West Coast rainfall, West Coast of India rainfall elsewhere already, but this is a nice paper that came out after so this came out in 22. And before we have talked about how the winds have shifted over the Arabian Sea and the trend of rainfall shifted with it, in the sense that the southern part of the west coast is getting less rain, let's say over Kerala. The northern part is getting more rain, but also the variance of the rainfall over the northern parts have increased. So northwest India into Pakistan is getting a lot of rain, extreme rain events as well. And we argued in a series of papers led by Baosheng Li, my colleague and friend, that this shift in the winds is related to the very rapid warming over the Middle East and the Mediterranean. There are other ideas by other people, but this one is more about how the rainfall characteristic has changed. So they look at the entire west coast and not separate into south and north western Ghats. West coast India's rainfall is becoming more convective, this paper says. A disastrous cloudburst and associated floods in Kerala during the 2019 monsoon season raised the hypothesis that rainfall over the west coast of India, much of which is stratiform, may be tending towards being more convective. If you don't know what that means, typically the rainfall is orographic, so the wind's southwest jet is coming along and it's climbing the mountains, so it's a forced ascent, and you get rain formation, orographic rain, which is not dynamically driven by warm temperatures at the surface, which reduces moist warm air to rise, expand, and then drives a circulation to feed itself into a convective system. So that's simply how I will put it here. So much of the rain over Kerala is stratiform, but maybe trending towards being more convective. Okay. As a first exploration, we sought statistically significant differences in monthly ERA 5 reanalysis data for the monsoon season between two epochs, 1980 to 1999 and 2000 to 2019. There's been a regime shift argued around this time as well. 97-98 El Nino was a strong one, and then there were extended very strong La Niñas, I think, that lasted for more than 2 years. The results suggest a more convective, so deeper and ice-rich cloud population in recent decades, with patterns illustrated in ERA 5 spatial maps. Deepening of convection above and beyond its trend in amount is also indicated by the steeper regression slope of outgoing long-wave radiation trends against precipitation that exhibited than that exhibited in interannual variability. Our reanalysis results are strengthened by related trends manifested in more direct observations from satellite and gauge-based rainfall and a Cape index from balloon sounding data. A lot of technical terms there. Hopefully you are already familiar with most of them. ERA 5 is a reanalysis data, blended data and a model which gives you the best reconstruction of dynamically interpolated data for the past. So you can study a lot of things, but you have to be careful because reanalysis products don't conserve things like energy and mass and so on. Nonetheless, they are very useful, and the idea is that even if rainfall decreases, extreme events can still go up. Mean rainfall may go down, but it may come down as extreme events. So all those things have to be kept in mind. And CAPE is convective available potential energy, which is an indicator of the instability in the atmosphere that is typically associated with convective rainfall as opposed to stratiform rainfall. So let's read a bit of the introduction and look at a few results and read the discussion. Model studies predict that the geographic distribution of precipitation will change in response to global warming. In the tropics, these changes have been reflected as wet gets wetter, increased rainfall in presently rainy regions, or warm gets wetter, so increased rainfall where the rise in sea surface temperature (SST) exceeds the mean surface warming. So these are the patterns: wet gets wetter, or warm gets wetter pattern. Furthermore, mean ocean warming leads to enhancement of extreme precipitation and a decline in light and moderate rainfall, especially in regions where SST warms most. The secular SST warming trend of the Indian Ocean is greater than most of the tropical Pacific and Atlantic, especially since the 1950s. I've discussed this elsewhere. You can look up in the podcast. The Arabian Sea has received special attention because its geographical position substantially impacts the densely populated bordering country India. Accelerated warming of the Arabian Sea since the 1995s is creating significant effects on intense cyclones over the Arabian Peninsula and the Indian subcontinent. That study also found that warmer winters and decreased decadal rainfall associated with warming of the Arabian Sea are accompanied by the decline of wheat production and vegetation cover, etc. But the main point is that the warming trends are not uniform. Indian Ocean gets heat from the Pacific and the Southern Ocean, and it in turn impacts the heat uptake by the Pacific and the Atlantic meridional overturning and so on. And then again, you have to also think about the circulation changes versus warming and thermodynamic changes. The west coast of India is considered highly vulnerable to extreme rainfall events and has witnessed several disasters. Drastic changes in the precipitation pattern over the west coast of India were noted by many people before, and Kerala, the southwestern state in India, witnessed extreme rainfall events in August 2019 and 2018 and 19, and since I think 2023 has also been pretty bad. Wayanad happened in 23, if I remember, which was a devastating landslide. Vijay Kumar et al. Detailed how the rain pattern that caused the 2019 flood may be attributable to the unprecedented warm near-coast SST anomalies and clouds unusually unstable and convective in nature. We inquire about whether the rainfall characteristics over this focused region, so they go from 73 to 77 east and 8 to 20 degree north, so they cover the entire range, portray the rainfall characteristics over this focus region portray any transformation in the recent past. We show that post 2000 there is an increased frequency of intense precipitation rate and deep convective clouds over the west coast, which may be associated with the rising SST of the eastern Arabian Sea, existence of greater instability and intensification and expansion of meridional overturning South Asian monsoon circulation. If you average the monsoon circulation, there is a meridional local Hadley cell. That's what is being discussed. So let's just jump to the results. I've skipped the details of the analysis. So they're comparing the SSTs after 2000 and before 2000, and you can see that the western Arabian Sea has warmed, and there are wind changes which indicate the jet that is accelerated, but actually there is also a shift that they are not focusing on here, and there is an approximate cyclonic circulation anomaly as well, and that's the climatology where you have southwesterly jet cross equatorial flow and brings boatloads of moisture into the Indian subcontinent, some back circulation here, but this is the focus region, so they haven't split it into north and south. They have taken the entire range over the ocean so that SST forcing can be understood, and we have discussed this before, that the interseasonal heavy rainfall events over the Bay of Bengal are related to the atmospheric instability. The SST background level is important. It's always about convective threshold from May to September, October, but here the rainfall is controlled by the ocean, because as the winds approach the mountain, the air-sea interactions begin to control the moist static energy, and hence heavy rainfall as well. Is it becoming more convective now? That's the argument in this paper. OLR, of course, if it is negative, it indicates convective activity, so it shows that there is a trend in the OLR also, not exactly coincident, but this is more consistent with the shifted winds, which I have discussed elsewhere before. And here is the climatology of the OLR, which I'm not sure why that is. Basically low, so rainfall, any low OLR would show rain, convective rainfall. Okay, so looking at the circulation changes in South Asian monsoon circulation and cloud structure. So these are composite of anomalous negative omega, that is vertical velocity in pressure coordinate, and meridional vertical wind vectors, overlaid with stippling, indicating areas that are statistically significant at a 99% confidence level between the two regimes, so post 2000 and pre 2000. So you are going from the equator to 25 north over the box region, and you can see rising motion basically to north of about 10 north, and subsiding corresponding subsidence in the meridional cell. So that means vertical omega is also stronger. And this is looking at the climatology on the other hand, which just keep in mind how it works. There is convection here, of course, orographically driven. This is the I keep forgetting. Okay, C, SCIW and SC. So wind, cloud. How can I forget? I just read the paper a few days ago, and then obviously I promptly forget. I'm getting old, folks. What can I say? I always think I'll remember them, and then I don't write them down because I'm relying on my memory, but I do 15 other things and record these only when I have time. So specific cloud ice water and specific cloud liquid water. See, these are not so intuitive, that's why I don't remember. Most of the things that are intuitive you tend to remember with practice. Anyway, that's my excuse, which is not a good excuse. So specific cloud ice water and liquid water, and there are some details. This basically indicates deeper convection and ice in the clouds, and this is how climatology looks in terms of what is D here. This again cloud water and liquid water. So those are the regime changes from before and after and before. So basically it just confirms that the ice water has increased at the upper level, which means more moisture being pumped up by deep convection and freezing, because as you expand and cool at the top you produce ice in the clouds. Okay, this is basically showing how Cape has increased, which is an indicator of deeper convection as well. All these the caption is very long. So we are looking at Cape during JJS, the monsoon season, spatial patterns of the 1998 to 2014 linear trend of average JJS deep convective cloud cover, that is B, and C is climatology of deep convective. Everywhere he is showing climatology as well. Spatial patterns of the 98, that depends on the satellite data. So linear trends of the average JJS convective rainfall from TRIM data becomes available from 1998 or so. That's why they are shorter period. Convective rainfall, statistically significance, climatology is shown. Box plot illustrating monthly average series MODIS cloud top pressure changes. So basically it's confirming that if you look at the changes in convective rainfall, and I already forgot what C was, oops, sorry, climatology of deep convective cloud cover and so on. So let me not spend too much time trying to describe. You can read the caption. My main point would be again that this signal here shows that maybe convective rainfall has changed over the entire stretch of the Western Ghats here, but when you make averaged differences of two decadal periods, then you have to be careful if 1 or 2 years are dominating it, or it's really a shift, consistent shift in a consistent shift and not dominated by 1 or 2 events. Okay, because here this would say oops, where did I, this one would say that there is OLR change is more negative here and not so strong here, but convective rainfall on the other hand shows a bullet point here as well. But this is on the ocean and this is on land, so maybe there is a difference in the way we look at it. Nonetheless, keep in mind that all these things, rainfall, probability shifts for the earlier period versus the later period, and this is the probability in rainfall millimeter per day. These are obviously cloud top pressure indicating it's decreased, again indicator of deep convection. So let's see what G, H, I and J are. They are climatologies, I'm sure. G, H, I, you know, it's hard to remember so many. G to J, the probability distribution functions of JJS rainfall prepared with the aid of gridded rainfall data. So basically it is showing that you have changed the contribution from the heavier events here have increased. Okay, that's the main message. The probability density function of heavier rainfall have increased. So they are different bins. So 50 this is the 0 to 50 millimeter per day bins between 0 and 400 millimeter per day. So they are basically again arguing that the moderate events have decreased and heavier events have increased. Sorry for the lack of preparation here. I'm should I complain? Excuse? No, I just didn't prepare so well. Okay, in summary, this study, I haven't been using the laser pointer. In summary, this study inquired whether observed trends in rainfall, rainfall intensity and cloud depth suggested by downward trends in OLR and upward trends in ice water may be indicative of an increasingly convective character of rain-making processes over the west coast of India. We further speculated that these may be connected to the Arabian Sea warming, greater instability and strengthened monsoon ascent over western India. If these trends are part of a forced climate signal, they may be likely to continue. Zonal and meridional SST gradients over the Indian Ocean region have also changed, suggesting how non-local effects such as circulation changes may also be playing a substantial role, for instance, steering low-level moisture transport towards the west coast. Even larger scales beyond the basin also mediate forced global changes, so more observational and modeling work to answer and extend our work. Title, it says. Internal consistencies among the available data sources examined here bolster confidence in the observed signal, but more big data work with instantaneous but not seasonally average data is needed to establish and understand the trends. Convection's character is ultimately expressed in the details of the thermodynamic profiles, the fine texture of clouds in satellite imagery, and short but impactful extremes in rainfall time series. If trends in these facets of convection continue, ecological and social consequences may be adverse even in places where bulk water resources are and will remain abundant. On average, climatologically, it gets a lot of rain. Nonetheless, my point would be that there may be no inconsistency in the wind shift and increased extremes on northwest India and Pakistan. All the flooding that's happening, even pre-monsoon rainfalls, crop damages have increased. But the decreased rainfall over here doesn't negate the fact that the rainfall is maybe coming as more convective heavy rain events, and the extremes are obviously documented. So the maximum rainfall always tends to be on the ocean, but obviously there is heavy rainfall over the Western Ghats as well, which is what we pay most attention to, and those are the extremes that are causing havoc in terms of landslides and so on. So the change in the characteristic of the rainfall, in addition to the mean changes and extreme changes, have to be considered altogether. But This one focused specifically on the change in the character in terms of deep convective rainfall events as opposed to stratiform rain events. Is that a permanent change? Is that a result of the northward shift of the winds as well, or is it a multi-decadal change? Then it will swing back and so on, are not clear. If the wind shifts are really related to the warming over the Middle East, then maybe it's a permanent shift, or the decadal variability will still express itself and the winds will slide back at some point. We don't know all these things, but I just included this here because it's related. It's already a couple of years old by the time I'm recording it, and by the time I post it will be maybe a few more months, but nonetheless just keep those linked podcasts in your head as we go forward to understand. A lot of details have been looked at on the core monsoon zone, peninsular India, the northern Himalayan foothills, because Himachal and other states are also having extremes, cloudbursts, landslides, and so on. So we have to keep tracking all these. Maybe they are all related in the dynamics and thermodynamics, but we tend to look at one thing at a time. Nonetheless, see you in the next podcast.